Hello everyone, in this session I'm gonna explain how to model a VOF problem. The geometry and the problem could be a floating object on the river, such as a piece of ice floating on the river. To model this problem, at first we should build the geometry and generate the mesh, and after that we could use any CFD solver such as Fluent. In this work we work with Fluent software. So at first we should use ICEM CFD to build geometry and mesh domain. So the geometry is floating ice on the river. You can see this geometry. This is body, this is a piece of ice, and this is our domain. And you can see boundary conditions. Pressure inlet at the inlet section and pressure outlet for outlet section, and a symmetry surface, because we want to model this problem with symmetry method in Fluent. And we have two walls, this wall and this wall, to model this geometry, the dimension of the geometry, the dimension of the domain. You can see them. So we open the ICEM CFD, and at first we should plot, and we should create some points. So click on this one, create point by location, and we should import the geometry and points. First is -8, 3.2, and 0. Create, and after that -8, 3.2, and 4. This is the second point. -4, 0, this one, -4, and 4, this one. Okay, this is 4 point of our domain. And next points 8, 3.2, and 0, this one. After that 3.2 and the 4, and after that -4 for this one, and 4, and last one, this is the last one. So this is our point of domain. After that we should create curves, so we should link all these points by curve. So this one, okay, this is our domain. The next step is to build our body, the floating ice. So I should input my points. The first one is -1, 0.25, and 0. 0.5, and after that this is minus and 0 and 0.5. This is 4 of our points. Next one is 1 point, and this one. Another thing is that this one. The next point is 1 minus 0.25, and this one, and the last one is this point. As I mentioned before, we should link all these points together. So okay, and this one. Okay, so we plot all points and curves, and in this at this step we should create our surfaces. So click on create surface, and after that this one, this is our surface. We can turn on this one to see solid view of surface. And the last one, the last surface of our domain, this is our domain. Okay, so in this section we can divide this geometry into two bodies. So I want to divide into domain, and after that our floating object. So for this one we can domain and click on this, and in this section we are choose our domain. So yes, we have our domain and our body. So we can create our surface of our body, create modify surface, and build our all surfaces. And the last one, this one that we don't use this one because this is a symmetry surface. Okay, but we have symmetry surface, and we have to split this surface into two surfaces and delete this one. So we use this one. Okay, for this one we should use this icon. This is a trim surface. Click on it, and as you see we have to choose a surface, this one, and after that we have to choose some curves to split with them, this one. Click OK, and after that we should delete this. Okay, I think it's enough for geometry, and we build the geometry correctly. After that we should define a body for our domain. So we should fluid body, we should choose 2 points in this domain, and this is our fluid body. This is the fluid. Okay, I think it's enough for this section. After building geometry, next part will be generating mesh. I think that it has no tips to say, so we assume that we already generated the mesh, and now we continue to the next step, which is CFD simulation by Fluent software. So we save this one and we generate the mesh. Let me show the mesh. This is my mesh, and I generated the mesh already. This is we have to use fine mesh close to the or wall, especially close to our floating object wall, to capture or all phenomena, because it is very important to capture especially our vertex. So after that we should open this mesh, we should export, and after that import this mesh to Fluent software and model problem with Fluent. Okay, so for the next section we should open the Fluent. Okay, at this time we should select 3D dimension, and I want to use two cores and use parallel solver. So click on OK. We're waiting to open this CFD solver, Fluent solver. Okay, the next step, at the first step in this part, we should call our mesh generated in previous section. We should import the mesh into Fluent software. To import mesh into Fluent software, we should click on this one, file, and after that read mesh, and this is our mesh fluent.msh, and open it. Okay, we use pressure base and transient, and check the gravity, you know, minus 9.81. This is our setting. This is general setting, and after that we go to the model. Click on multi-phase and choose volume of fluid. We have two Eulerian phases, and we check this one, open channel flow, because this is a VOF model and open channel flow problem. We check this one, we check sharp, this is sharp, and after that we should, to capture body forces, we can use we can check this one, implicit body forces. So this is our setting for this part. Okay, and after that we have to choose and viscose model, and we choose K-omega-SST. I think it's good and a proper model to this one. Click OK. Okay, after that go to the next one, material. This is air, and we have to add another material because we have two phases. The first one is water and another one is air, so we have to add another material. So Fluent database and water liquid, and copy this one, and you can say water liquid in this section. So go back to this one, click on model and multi-phase, click this one. This is phases, and we have to choose phases. It is very important because of some points you have to notice about this section. For primary phase, edit primary phase should be air, and the secondary phase should be water liquid. It's very important because the Fluent tutorial said secondary phase should be water, and you have to check this one. So we close this one, and after that I should go to the boundary condition. So we click on boundary condition and go to the inlet boundary condition and choose this one, and we have to choose pressure inlet. for inlet. Click on open channel, and it is very important, secondary phase should be phase 2, or phase 2 is water, and based on Fluent tutorial we have to choose water as a secondary phase. This is secondary phase, and for this one we have 3 options, but I think it's proper to use free surface level and velocity. Free surface level, velocity magnitude, and bottom level. Velocity magnitude we consider it as 20, but what are these free surface level and bottom level? Let me show what are these. As you see in this picture, we have a river, the level of river, this one, the surface of river, and the distance between the surface of the river, the level of river, and the bottom or channel is 4 meters, you know. So in this one we should use this -4. Bottom level is -4 meters, and free surface level is 0 because our coordinate system was located, as you see, coordinate system is here, and we should consider it as 0. Okay, and this one we can change to from free surface level. Click on OK, and after that we go to the outlet. We should choose a pressure outlet, multi-phase, open channel, and this one free surface 0 and bottom level -4, and this one from free surface, click on OK. This is a symmetry, right and up. We can use up surface, up should be pressure outlet, and multi-phase, open channel 0 and -4. This is for this one. So after that, after boundary condition, we should go to the solution method. Solution method, I think simple, it's proper, but piezo is another option that we can use, piezo. And after that we go to the monitor, and we can use this one. This is, I think it's enough, but we can uncheck this one, check convergence, you know. Click OK, and click drag surface. I want to capture drag force on all surfaces of the body plot, and this one. So I think it's enough. Go to the solution initialization, compute from inlet. It's better to choose 0 instead of 20. So I think it's a good idea to choose 0, 0, 0 for all domain. So we use flat. Open channel initialization method should be flat and initialize. For this one, as I mentioned before, we checked transient method, so I think it's enough to use this one, and 1000 time step. For each time step, I think 50 iterations enough. So we can write save and data, and we can use this one ICE, and click on OK and save case and data. Now click on calculate to start our calculation. This kind of problem, in my opinion, are time consuming, and you have to spend a lot of time to convergence these kind of problems. So I think it's enough for this section. At the next section, we will export Fluent data to CFD post and show some. Well, at the final step, we click on CFD post and we open it to show some result of our this problem. Click on file, load result, desktop, that file, and open it. Well, you can see the this one, the geometry, the body, and the domain, and these are wireframes of our geometry. I think the first thing that could be impressive is using volume rendering. Volume rendering variable. We want to show phase 2 volume fraction and click on apply. As you see, the result show clearly that this one, and another thing is that we could use isosurface, and phase 2, I think 0.5 is better. You can see this one, this is better to show that. And okay, I think it's enough for this section we model the VOF problem, and we use open channel method, we use Fluent software, we use ICEM CFD mesh to model this one. I think it's enough. At the next step, the next section, I'm gonna talk about dynamic mesh and how to use dynamic mesh to model airfoil, to model turbines, and other type of rotary blades. Thank you so much. Have a good time.